All right, everyone, let's make this quick. You probably realize that one of the problems that we have is that our acceleration right here, we are always adding the force, right? So we're kind of always accumulating these forces right here as we are stepping in our simulation. What we really need to do is basically kind of set correctly the acceleration in the position of the nose, right? This forward velocity that we are pointing in the nose direction. So we're going to have to set the acceleration and only considering, right, this frame that we are right now, right, in the correct position of this, in the direction of the force that we are in, the thrust force. So set acceleration, we're going to have to set the ship acceleration Vx is going to have to be all the three components of the vector. So the Vx needs to come from right, I need to get the new nose vector, right? So it's going to have this difference of these velocity vectors before and now, and only get this difference. So you know what? I think I'm going to have to get the subtraction between, let's just say, a forward velocity, right? We're going to have this forward velocity minus the current ship velocity. And I'm going to have to compute this forward velocity above. So we're going to have to compute the forward velocity. We're going to have to do this right now. And then the ship acceleration Vx is the forward velocity Vx minus the ship velocity dot Vx. And of course, this has to be for all the components y and z, and y and z. Because this subtraction right here, what I need to compute is I need to compute something called, let's just declare here, a forward velocity vector right here. So forward velocity. The reason why I'm declaring this forward velocity is because I need to get, actually before the force here, I need to get the difference of direction of the new velocity. So I'm going to need to compute the forward velocity Vx. This needs to be the new velocity pointing at the new nose direction, right? So I'm just adding a couple of notes here for me to think what I'm doing. So this forward velocity is the new nose velocity. Let me just change this to new nose velocity. So I think that's going to make more sense. So the new nose velocity, nose velocity right here, let's just change this to nose velocity. This nose velocity is the velocity value along the new nose direction that we just computed here, right? This forward nose that we just computed for this frame. So this is going to be the forward, ship forward dot Vx, but I need to have the intensity, right? So what is the intensity of the velocity right now? Well, it is, I need to get the length of the velocity, right? So it's going to be, let me just compute the length or the magnitude of the velocity. I think we do have the current magnitude, right? The intensity, the current speed, right? We have the ship speed. I think we declared speed in ship.h. Yes, we did. So we do have this instantaneous velocity value, right? So I can use this ship.speed. How do I get the length of the velocity vector, right? So how do I get the length of a vector? Well, it is that Pythagoras theorem, right? I need to get the hypotenuse of that kind of triangle thing that I have. So it is going to be x squared plus y squared plus z squared, and then the square root. So it's going to be ship velocity Vx squared, and then plus Vy squared, and plus Vz squared. So this is going to, if I take the square root of all of these things, I'm going to get the magnitude of the velocity, right, at this moment in time. This is going to be, let's just use that libgt square root. This is this velocity. think this one has to be 0, right? It's not 12, it's 0 square root. Yeah. So I take the magnitude of this value, right? Because we are just getting the length in this case. So the ship speed, I get the ship magnitude that I just computed, speed, along the forward axis, right? So let's just get this thing, and since we multiplied, we have to shift by 12. Does that make sense? Multiplication, shift by 12. So this nose velocity, I need to have all the other components, y and z, and then is the speed times the y and the z. So do you see we are getting the nose velocity? This is the new nose direction, right, that we are pointing at. I cannot just go and use the old one. I have to get this new nose direction because the force that I'm applying, I need to start my acceleration in the direction of the new nose axis, right? So this forward axis that I have right now, which I'm getting from, right? I'm getting from the subtraction, the difference between the nose velocity, that's what we're calling. So the nose velocity, right? The new nose velocity Vx minus the old ship velocity Vx. So this subtraction right here gives us the start orientation, the start direction of our acceleration. Cool. So I think that is it. Let's just see how this looks. Did I forget anything? No, good news. So if I come here and I refresh, let's just see if these values make sense, right? Since now we're only getting the difference between these directions that we have. So if I start accelerating, slowly moving forward, and left and right. Why is it so slow? Feels like we don't have kind of power, right, on our thrust vector. Let's see. Compute the thrust force vector based on the thrust magnitude that we have. Do you think our thrust can be, let's just reduce a little bit. Instead of 12, let's just put 6 here. Again, I'm just going to have to find something. This is just me kind of reducing a little bit thrust, right? I could change the intensity, but let me just change the thrust shrinkage that we are doing, right? So shrink a little bit less. Let me just see. Okay, and if we come here and we refresh, how does that look? If I go, okay, better. Ooh, I like that. Okay, that fixed a lot of things. And I can go up and down and up. Oh, this is so good. Oh, so good. Of course, our camera, remember, we are not positioning the camera behind the player. We are always positioning in this negative z axis, right? But do you see? If I go right, if I go left, I think we found some nice factors here, right? If I go and I accelerate this direction, woo, things are looking super cool now. Right, so I like that. Maybe I can go and revisit these factors later, depending on how big or how small I want my intensity of the thrust. Maybe shrinking by 6 is not the best idea, but you know what? I think we found a nice movement effect here. I think it's okay for now. So what I want to do now is, the last thing that I want to do right now in this lecture is, remember how this camera position, we were forcing the camera to always be behind the ship, right? Behind and a little bit up the ship. And the way that we did that is basically we just went there and we changed the Vy position, right? So it's only the position of the ship, Vy minus 500 up, and the position of the ship, Z minus 800. Let's just change this to respect the nose vector of the ship, right? Because we should always position our camera behind the ship, considering the nose direction of the ship, right? The forward axis of that ship. So you know what, I'm just going to send this over to you. I want this to be a small exercise for you to do. Just go ahead and try to change these lines of code right here to actually consider and respecting the forward axis, right? We have to always position our camera behind the ship, but we have to consider the orientation, right? The rotation of that ship. So go ahead, try to implement this thing, respecting the forward axis, the up axis, and I'll be back very soon with my implementation as well. I'll see you soon.